Is there a frontier we'll never cross? Are there places we'll never reach no matter how hard we try? The answer is yes. Even with science fiction technology, we're trapped in a limited bubble of the universe and the finite matter within it. How much of the universe is available to us, and how far can we go? When we look at the night sky, we might think it will always be there. Stars are born and die in a cycle that seems endless, but it's not. Let's take the Milky Way as an example. With a diameter of up to 200,000 light-years, it contains between 100 and 400 billion stars. How many stars are born here each year? Thousands? Millions? The answer is surprising. Only 3. 3 new stars per year. 95% of all the stars that will ever exist in the universe have already been born, and we're in the tail end of the star formation era. We're at the beginning of the end of the universe as we know it, as the formation of new stars continues to slow down. But there's more. It turns out that the universe is moving away from us. The Milky Way isn't alone. Together with the Andromeda Galaxy and 50 other dwarf galaxies, it forms the Local Group, a region of space about 10 million light-years in diameter. This is our galactic neighborhood. Hundreds of galaxy groups like ours form the Laniakea supercluster, which is just one among a myriad of superclusters. In total, there are about 2 trillion galaxies that make up the currently observable universe. Unfortunately, even if we could travel at the speed of light, nearly 94% of the galaxies we can see will always be out of reach. Let that figure sink in. The mere fact that there's a limit and that so much of the universe will never be accessible to humans is somewhat chilling. Why are all these galaxies beyond our reach? The answer goes back to the very origin of galaxies, the Big Bang. In simple terms and greatly oversimplifying, about 10 circumflex 36 seconds after the Big Bang, the young universe was a very small bubble of energy. However, it wasn't completely uniform. The density of some parts was slightly higher than others, which had enormous consequences. In a process called cosmic inflation, the observable universe expanded rapidly, from the size of a marble to trillions of kilometers in a trillionth of a second. This expansion was so fast that all those tiny density differences stretched from subatomic to galactic distances. That's why the entire universe is a set of regions of varying density, bubbles of universe filled with a bit more matter than the space around them. After this brief but powerful inflation concluded, gravity began trying to pull everything back together. Inside the densest bubbles, gravity won, and over time, they became groups of galaxies, like the one we live in today. The local group is our bubble of the universe. But on a larger scale, outside the densest bubbles, the expansion of space never stopped. This means that our local group is surrounded by a lot of matter, but none of those structures and galaxies are gravitationally bound to us. The more the universe expands, the greater the distance that separates us from other gravitational bubbles. And the situation is even worse as the expansion of the universe is accelerating. Since we don't know why, we've invented the concept of dark energy, which should be imagined as an invisible effect that accelerates the expansion of the universe. These concepts deserve their own video to explain them in detail. For now, let's be content knowing that the universe is expanding faster and faster, which means there's a cosmic horizon around us. Everything beyond it is traveling away from us faster than the speed of light. Therefore, everything that crosses this horizon is irretrievably out of our reach, and we will never be able to interact with it again. In a way, it's similar to the event horizon of a black hole, but surrounding us. 94% of the galaxies we can see today have already crossed it, and we've lost them forever. Wait a minute, if we can't interact with them, how can we still see them? We see things through light, and although its speed is the fastest way to travel through the universe, it takes time to go from one point to another. Every second, light reaches us from trillions of galaxies that have already passed the horizon because they were much closer to us when that light was emitted. We see their remote past and their remote location. That's why the observable universe is much larger than the universe we can actually interact with. In a way, the universe offers us a grand spectacle, showing us what will always be out of our reach. We have no idea what those galaxies look like today, and we never will. But we'll be able to keep observing them for as long as their light reaches our telescopes. This means that the observable universe still seems to be growing, as more and more light reaches us from super distant galaxies emitted billions of years ago, for now. One day, all the bubbles of the universe outside the local group will cross the cosmic horizon. When they do, their light will stop reaching us, and from our perspective, they will fade into darkness. Every second of our lives, 60,000 stars cross the horizon. Since this video began, about 22 million have gone out of our reach forever. Well then, if 94% of the observable universe is beyond the cosmic horizon and gone forever, we still have 6% technically within reach, which is a lot of matter. All the galaxy bubbles that are less than 18 billion light-years away. They're still moving away, but slowly enough that we could physically reach them, although the opportunities diminish every second. Everything more than about 5 million light-years away is receding. But the closest galaxy groups are the slowest. That's why there's a time window to jump to other galaxy groups. However, the challenge is extreme, even for Type 3 civilizations. Even if we could travel at the speed of light, a trip to the Milky Way group, the closest galaxy bubble to the local group, would take 11 million years. If some kind of super advanced and super motivated civilization were to take on this challenge, its possible sphere of influence could reach hundreds or thousands of galaxies. Although as time passes and the universe grows, they will separate forever. It's pretty safe to assume that humans won't make this journey, at least not with technologies that seem very remote today. For us, the local group is likely the largest structure we'll ever participate in. Simply traveling between stars would already be an achievement of epic proportions. Colonizing our cosmic backyard would be an incredible success. That means 0.00000000001% of the observable universe. As dark energy separates us from the rest of the universe, the local group will become increasingly united. In a few billion years, all its galaxies, large and small, will merge to form a giant elliptical galaxy that has already been dubbed with the unoriginal name Milkomeda. This process could even cause enormous gas clouds to collide and form stars again for a while. This new light will be fabulously received because, at some point, the galaxies outside Milkomeda will be so far away that they'll be too faint to detect. When this happens, we will never receive any more information from outside the local group. The universe will withdraw from view. Beings born in the distant future in Milkomeda will believe that the universe consists only of their own galaxy. When they look into deep space, they'll only see emptiness and darkness. They won't observe the cosmic background radiation, nor will they be able to discover the Big Bang. They'll have no way of knowing what we know now, the nature of the expanding universe, when it began, and how it will end. They might think the universe is static and eternal. Milkomeda will be an island in the darkness, which will grow increasingly darker. Even so, with its trillions of stars, the local group is large enough to keep us entertained for quite a while. After all, we haven't yet figured out how to leave the solar system, and we have at least billions of years to explore our galaxy. Moreover, we have the incredible luck of living at the perfect moment to see both the most distant future and the most remote past. All we have to do is look at the night sky. Although isolated, the local group is our home, a spectacular place without a doubt.